right, continuing on. They're all going to rotate around so that they move in a path parallel to the celestial equator. Or what I couldn't do this, or what I can do, is extend this so we see the whole celestial sphere. Normally can't because the ground gets in the way. But these objects would make a path that goes all the way around. They would all make circles all the way around like that, because everything is spinning around the north and south pole of the Earth. This is the south celestial pole down here. Well, that causes some interesting things to occur. First of all the stars up here you see go around and around, and these stars never go below the horizon. Here's the horizon. So those stars are up all the time. We have a special name for these stars. These stars are called circumpolar stars. All right, circumpolar stars are stars that never set. You can see them any time of the year. They're always up in the sky. They change their altitude, but they're always up in the sky. And over here, you see stars down here are going to go around the south celestial pole. These stars over on this side, we will never see from this latitude. These stars are called never visible stars. Okay. And then we have all these stars in the middle, and they rise and set, and we see different stars at different times of year. These stars, you might have heard of some of them. This is like the Southern Cross, Alpha Beta Centauri, these kind of stars that you can't see from here. You can only see them if you travel to a different location on the Earth. And then circumpolar stars up here, also how many of them are circumpolar depends on where you live. For us, in Commerce, we only have a few because we're fairly close to the equator. Like the Big Dipper is partially circumpolar, Little Dipper is completely circumpolar, a constellation like Draco, the dragon. So let's look at how this changes as we move to a different place on the Earth. So for example, let's say Herb moves to the North Pole. All right, North Pole Herb. North Pole means they're at a latitude of 90 degrees. Okay? If you're on the North Pole of the Earth. All right, there's some weird things that happen if you're on the North Pole of the Earth. First of all, if you're on the North Pole of the Earth, is there any east or west directions? Remember, if I'm standing, the North Pole right here, I'm standing here. If I walk this way, I'm going south. But if I walk this way, I'm also going south. And if I walk this way, I'm also going south. So from the North Pole, there is only one direction, it's south. So you can't really put east and west down here because it all is south. Weird location. That happens on the South Pole as well. But we do know by definition that straight over Herb's head is the North Celestial Pole. Because that's how we define the North Pole, the Celestial Pole, is it was straight above the North Pole of the Earth. So if you're standing at the North Pole, the North Celestial Pole is at your zenith, at the highest point in the sky. Okay? Which means that the angle between here and here, between the horizon and the North Celestial Pole, is 90 degrees, which matches your latitude, which we said has to be the case. This always has to match your latitude. Okay? Where's the celestial equator? Well, it's 90 degrees from that, so the celestial equator is exactly on the horizon, or the celestial equator matches the horizon. And if we have a star, how does that star move if you're on the North Pole? Well, that star is always going to go parallel to the celestial equator, so in this case, the star is going to go around like this. And a star up here is going to go around like this. The star here is going to go around like this. So stars, if you're at the North Pole, never rise or set. They just go around. So if you see a star, it just goes around like this. Never gets higher, never gets lower. It does that forever. Okay? And higher stars just make higher circles. And the North Celestial Pole would be straight up over your head. What that means is, since all stars never set, then if you live at the North Pole, all stars are circumpolar. Or if you're at the South Pole, all stars are circumpolar, you just see the other half of the celestial sphere. So if you're on the North Pole, here's our celestial sphere. If I made it go straight up, this is the celestial equator right here. All the half, you would only see this half of the sky from the North Pole ever. You would never see these. Half of the sky would be never visible. But these stars would be up continuously, just circling around like this. If you lived on the South Pole, it would be the same way, except it would be flipped over. They would see this half of the sky and never see this half of the sky. And there are actually telescopes at the South Pole. There aren't any at the North Pole. But at the South Pole, at the research station, they have telescopes there to study very special things that you can study in Antarctica that you don't study anywhere else. Let's go to another extreme. Let's say we go to the equator. So here's Herb at the equator. Okay. So here's Herb. Now I do have north, south, east, and west directions. So, where is the North Celestial Pole? Well, at the equator you have a latitude of 0 degrees, either north or south, it doesn't matter. But it's still 0 degrees, so where's the North Celestial Pole? The North Celestial Pole is right on the horizon. Because it's 0 degrees between the horizon, so it's exactly on the horizon. And exactly on the other horizon is the South Celestial Pole. And 90 degrees away from that is the celestial equator. So the celestial equator is straight up. Which makes sense because that's how we defined it, is it's directly above the celestial the equator of the Earth. So the celestial equator is straight above you, or goes through your zenith from east to west straight through your Venus. How do stars move down here? Well, if I have a star like this, it's going to follow or parallel the celestial equator, so it's going to go straight up and straight down. All stars are going to go straight up and straight down. So every star you see, if it's rising, is going to rise straight up, go straight down. Even the ones over there are going to go straight up, straight down. So all stars actually are up for exactly 12 hours and are set for exactly 12 hours. And how many are circumpolar? None. So there are no circumpolar stars. But there are also no never visible stars, meaning you can see every star in the sky at different times because you can see the whole celestial sphere if you're at the equator. That's why astronomers like to put their big telescopes close to the equator, because the closer to the equator, more of the sky you can see. It actually is not an advantage to be at high latitudes. It's better to be closer to the equator. All right. Now, you will have a homework assignment where you have to calculate the altitude of this celestial equator from different places. So let me just do one as an example for you. So what is the altitude of the celestial equator from latitude 52 degrees north? All right, when you do these, you always have to draw a picture. I expect to see a picture every single time. So we do these are called Herb diagrams because of our astronomer Herb. So here's Herb, right here. North this way, south this way. Notice you don't have to do it three-dimensional. I just do that before to kind of give you a better spatial perspective. But here, what we do is, how you do this is you find out the latitude. You know the latitude always tells you the altitude of the North Celestial Pole. So we're going to go up 52 degrees. so that angle is 52 degrees. This is the north celestial pole. And then from the north celestial pole, you always go 90 degrees. So I'm going to make that exactly a 90-degree angle to the celestial equator. And then when I ask for the altitude of the celestial equator, what I really want is that angle right there. That's what we're trying to find. And to get that, you just take 180, because this is half of a circle, minus 52, minus 90, gives me what's left over here. So I'm just subtracting off those two parts. Whatever's left has to be that angle. And when you do that, you're going to get this is 38 degrees. So my answer is 38 degrees. That's how you do it. They're not hard to do. Okay? All right. We will come back with more stuff next time.